Assalamualaikum and hello everyone. Okay, in this video what we're going to do is actually we're going to continue our example. So on page 3, let's look here. Okay, example number 3. The electronic configuration for element J and K are given as follows. State the period, block and group. Okay, so for example, if the question itself does not mention the order of what what is the period, block ataupun group, sebenarnya hint nak ingat ataupun based on the electronic configuration, okay, sebenarnya tengok ni lah, PBG, PBG macam PUBG dulu juga kan. Okay, why dia mention yang PBG? Because actually period ni bit straightforward, we're gonna just take our highest end sahaja. Okay, block ni we're gonna look at the valence electron. Group ni is the last one. Why? Because from the group itself, group ni it must depends on the block. So why did I mention about that? Sebab kalau P block, we're going to add in electron on S, electron on P, and plus dengan 10. Kalau D block, we're going to add in S plus dengan electron on D. Okay, so that's why lah, to determine the position, the simplest one, the first step, determine the period dulu, then the block, last but not least, is actually the group itself. Okay, so now let's look here. State the period, block and group for J. Okay, so J ni, dia punya electron, the highest one, the valence electron for this case is actually 3s3p lah. Okay, so for J, what is actually our period? It is period 3, okay, the highest end. Okay, what is the block? So, dia adalah P block. Okay, what is actually the group? Kalau P block, remember, we have add in S plus P plus 10. So, he is actually group 13. Okay. Now for K pula, here is J, here is K. So the same goes here, period 3, P block. Okay, and then group the P block 2 plus 5 plus dengan 10. So group 17. Okay, next, state the oxidation number for element J and K. Okay, so remember that the oxidation number tu, okay, I'm just gonna write down here. Walaupun kamu ingat, ke tak ingat pun tak apa. Kita akan revise balik. The oxidation number ni, it could be positive if it's donate electron. It will be negative if it gain electron. Okay, the act of donating organ electron is actually for the atom itself to achieve octet. Okay, so in this case sahaja, it is easier for you if you write down the electronic configuration the old way yang dot tu. So dalam case ni, for J itself, electronic arrangement adalah 2.8.3. Okay, again, why 2.8.3? 2 in the first shell, second shell ni n equal to 2 ada 8 electron, the third shell ni we have 3 electron. Okay, last one ni, for K is 2.8.7. Okay, so again, as we look, remember, if it donate the electron, it will be positive. If it's gain electron, dia akan jadi negative. So for the J itself, element J ni, what would happen is that it could donate 3 electron, ataupun to achieve octet, it could receive 5 electron. Which one is the more easier one? Is actually the lowest number lah, yang 3 ni. Okay, so does it donate ataupun gain electron? So if it donate, positive lah. So for J ni, the oxidation is positive 3. For the K itself, okay, so it could be accepting 1 electron, or it could donate 7 electron. Which one yang easier for it? The smallest number, 1 lah. Okay. For 1 ni, is it accept or gain electron? Accept ataupun gain, donate ataupun gain electron. So it will be gaining electron. So there is negative 1. Okay. Last but not least, okay, write the molecular formula for the compound form when the elements J and K react. Okay, so contohnya kan, for example, I'm gonna write down we know that kamu yang familiar the one that you're familiar with. For example, we have our sodium kan. Sodium, we know that the oxidation number positive 1, Cl negative 1. So jadi Na plus dengan Cl minus. So we know it will form NaCl. Okay. Why NaCl? Because actually dia punya charge is the same. For if we have this case, kita buat zinc chloride. Okay. Zinc is 2 plus. Chlorine is negative 1. Okay, when we add zinc 2 plus Cl minus, it will become apa? Okay, so jadilah zinc Cl2. Tapi dalam case ni it's not balance kan? Okay, sebenarnya 2 Cl kat sini. Okay, what happen is that dia akan cross, apa ni? The charge ni will be cross lah. Cross multiply lah. Macam tu lah. So, dia jadi zinc Cl2. Macam tu lah. So, dalam case ni, J ni, so this case, J3 plus dengan K minus. So, what would happen is that dia akan form J ni akan jadi 1 lah sebab charge of K ni is 1 kan. So, K ni, it will become 3. JK3. Itu sahaja. Ini sebenarnya equation ni tak payah pun tulis. Kalau nak make sure it's balance, ini tambahlah 3. Okay. So, macam tu lah. Tapi, question ni nak ada only the molecular formula kan. So, padamlah yang ini. Tak perlu pun tulis yang ni. Okay, yang ini JK3. Nak buat ni pun boleh juga. So, ni jawapan dia Okay, it's JK3. So, how do we get here? Kalau nak write the molecular formula ni, first thing first, determine dulu oxidation number dia. Okay, then, kamu writekan dia sekali lah. Yang ni, this is just an example. Kalau tak perlu pun buat equation ni. It's just that it is more clear to you lah kalau we write down the equation. So, that's for example 3. Example 4, I believe you could try yourself. The last example that we're going to discuss together is actually example number 5. Okay, so let's look here. The proton numbers of N and O are 16 and 37 respectively. Okay, so determine the block of each element, determine the period and group. So first thing first, what we're going to do is actually write down our electronic configuration. Okay, so for the electronic configuration, 16 oxygen. It's not oxygen. It's actually, ni bukan nitrogen and oxygen Ni kiranya unknown atom lah. So N ni here is actually 16. So they want S2, 2S2, 2P6, 3S2, 3P. Betul tak ni? 10, here is 10. So 3S2 is 12, 3P4. Okay. So that's for example, that is for N. How about atom O? O ni 37 kan? Tak pernah sebanyak tu buat lagi. So let's do it together. 1S2, 2S2, 2P6, 3S2, 3P6. Ini misal buatnya 4S2, 3D10 kat sini ni. So here is 10, here is 18, here is 12. Complicated pula nampak macam ni. So here is only 30. So, we do have another 7 more. 4S2. Okay, 4P6 pula. 4P6. Okay, is it enough? So, here is 10. Nak juga buat macam ni kan. Here is 20. So, here is 6. So, baru 36. So, after 4P6, it's not 4D1. We're going to fill up 5S dahulu. The S orbital first. So, dia akan jadi 5S1. Okay. Determine the block of each element. So, kalau N ni, N is actually P block. Okay, O ni, tengoklah. Here is actually our S block. S block. So, this one. Just gonna ni. Okay. So, determine N period and group. N ni, period 4. N to period 3. K group. Again, for P block, we have to add in S plus P. Can't see clearly. S plus P plus 10. So it is actually group 16. How about O? O is period 5, the highest end kita, and group 1. Okay. Next, state the oxidation number. So, oxidation number ni senang kalau ni sebut kat sini. I'm just going to write down. Here is 2.8.6. Here is 2.8.18.8.1. Gitu panjang. Okay. So, here again, it could be positive or negative. Any smallest number lah. So, sebenarnya it is easy for it to gain 2 electrons. So, for any, kita nak gain 2 electrons. So, if it's gaining, it's negative 2. Kalau O ni, it is easier for it to donate electron to achieve octet. So, jadi positive 1. Okay. Here, give a set of possible quantum number for the 11th electron of N. Yang lain sikit. Quantum number, you're familiar. Tapi ni dia macam the 11th one. Okay, so how we're going to do it? Calculate lah. Okay, so we're going to calculate. Okay, so here is actually baru the electron. Kat sini is here 2. Here is 4. So here is 10. Okay. So the 11 electron ni is actually pada yang 3s1 ni kan? Pada 3s orbital. So the 11 electron is actually on our 3s. Okay, why? Because I calculate it here lah. I'm gonna write down. Yang ni. S ni. So here is 2. Maknanya contohnya second electron ni lah. So here is 4. Here is 10. So the 11 electron is actually pada 3s. Okay, so for the 3s, so what could be the possible quantum number? And LMS dia, it could be 3, 0, 0, positive half. Or you could also write it as 3, 0, 0, negative half. Okay, so yang ni calculate lah the number of electron. Here, the 33rd electron of O. Okay, yang ni copy paste kat sini lah bagi nampak. The 33rd electron. Okay, 3D kat sini, 3D10. 4s2, 5s1. I'm just gonna delete this part. Okay, the 33rd. So, we know that, okay, bila Miss kira, when I calculate, here is actually 30. So, the 33rd electron is actually in this part lah. For this part, yang 4p6 ni. Okay, so what is actually the possible quantum number? It would be NLMS. Make sure buat macam ni. So, first possibility, N equal to 4. L dia, remember, L2 must depends on the orbital notation lah. Kalau P ni, L equal to 0, dia adalah S. L equal to 1, dia adalah P orbital. So, dia jadi 4, 1. So, dia punya M, it could be positive 1, 0, negative 1. So, first one, I'm going to write down positive 1. So, positive half. Okay, give a set. Tapi, boleh juga, contohnya kalau kamu nak buat. So, okay, I'm going to write down all lah. Supaya senang. It could also be written down as 4, 1, negative 1, positive 1, negative half. Apa lagi yang boleh? Sebab ada 4, ada 6 possibility kan? So, yang ini Miss nak buat when M tu equal to 0. Or, you could also write down this part for negative 1, negative 1, negative 1, negative 1. Okay, so remember that when L equal to 1, M could be positive 1, 0, negative 1. So, that's why lah ada possibility ni. Okay. So, again, so that's the last part of example number 5. Example number 6, I believe you could try yourself.